you'll be asked to differentiate something called a composite function. A composite function is when you have a function inside of another function. And I like to more think of these as questions that contain brackets. Now, when differentiating something like y equals x plus 2 to the power of 2, you can pretty easily expand that and then differentiate. Similarly, if you have a function of x equals x to the power of 2 all to the power of 3, you could expand that. It might be a bit longer, but you can do it and then differentiate. But say we have that power becomes 10, we don't really want to have it to expand that. So there are rules to deal with this. Now, this question, y equals x plus 2 to the power of 10, is a composite function. Because if we look carefully, it's actually just a function to the power of 10, and then x plus 2 has been put inside of it. So we could look at this by saying, well, let's just let u equal x plus 2. Now we could rewrite this function as y equals u to the power of 10. So you can see that was the original function and x plus 2 was placed inside. Now, if I were to differentiate y equals u to the power of 10, I'm going to get dy du, bring the power in front, reduce power by 1, 10u to the power of 9. Now, that's all good, but that's not dy dx. So we have to continue working with this to get an answer. Now, if I look at what dy dx could equal, I've already got a dy du. Now, the reason why we use this form of function as opposed to fx is that we can sort of treat this like fractions. In order to get dy dx, I need to get a du on top to cancel the du on the bottom and the dy du, and I need a dx on the bottom, which means I need du dx. Well, du dx can come from y equals x plus 2. Du dx is just 1. So now I can put this into this rule and get equals dy du is 10u to the power of 9 times du dx is 1. Now, if you were to differentiate y in terms of x, you'd expect there to be x's, so we can substitute u as x plus 2 back into this equation to get 10 x plus 2 to the power of 9. Now this rule here, this is called the chain rule. And basically what it says is that you should differentiate the original function on the outside and then multiply by the differentiation of the inside function. This could be written as a rule by saying if you have fx equals some function g and then some smaller function inside, we get f dash x equals, well, you differentiate g, you leave whatever is inside g alone, and you multiply by the derivative of the inside, so h dash x. And we're going to use this rule to speed things up. So for number 2, I could rewrite this firstly as y equals 2x plus 8 to the power of 1/2. So then to differentiate, I'm going to use this new rule by differentiating the outside function. So that's half, leave the inside function, reduce by 1, and then I'm going to multiply by the differentiation of the inside function. The inside function being 2x plus 8, so differentiate that, I get 2. Simplifying, the half and the 2 cancel. So, and then I can bring this negative power to the bottom. I get 1 over 2x plus 8 to the power of 1/2, which is 1 over the square root of 2x plus 8. For our next function, we've got something all on the bottom. Now, you were allowed to bring the variable to the top when it was just one thing. But when there's lots of things, and by lots of things I mean something with a minus or a plus, we can only treat this as if it's all to the power of 1. So I can rewrite this by bringing all of that to the top and saying 5x to the power of 2 minus 4 all to the power of -1. Then I can differentiate this just as I was doing. So dy dx, bring the power in front, rewrite the original middle inside function, reduce the power by 1, times by the differentiation of the inside function, which is 10x. This can be simplified by saying the negative 10x stays on top, and the thing in brackets with the negative power 5x squared minus 4 can go to the bottom. Our next question, same rules. Bring the power in front, rewrite the inside function just as it is, reduce the power by 1, so that's the outside differentiation done, and then times by the inside, I have 10 minus 6x. Now I need this in brackets because if I don't have brackets, then this function is only multiplied by the 10, not the 6x, so I need it in brackets. I can simplify this simply by just doing 5, 10 minus 6x, 10x minus 3x squared to the power of 4. Finally, I'm going to treat this whole bottom as if it's the power of 1. So I'm going to bring it up. You get 2, 5x plus x to the power of 4 to the power of -1. So to differentiate, I'll bring the power in front, -2, rewrite the inside function, and reduce the power by 1. That's the outside function differentiated. Then I'm times by the inside function differentiated, that is 5 plus 4x to the power of 3. To simplify, anything without a negative power can stay on top, so that's the -2 and the 5 plus 4x to the power of 3. And then the -2 can go to the bottom by saying 5x plus x to the power of 4 to the power of 2.